Welcome back to the series on Class 7 Maths. In this video, we are going to learn about integer division. So we will see how to divide one integer by another integer, and we will also see some important properties of integer division. So we know how to divide two natural numbers, that is two positive integers. So we can compute things like 35 by 7 is 5 and 35 by 5 is 7. But what we don't know yet is how to compute minus 35 by 7 or 35 by minus 7 or minus 35 by minus 7. So we don't know how to handle negative integers when it comes to division. And that's what we are going to learn in this video. We already know about division of natural numbers. So we know how to divide two natural numbers. So let's assume that a, b and c are natural numbers, that is positive integers, and they are such that a times b equal to c. So in the previous example, a would be 7, b would be 5 and c would be 35. And since division and multiplication are just opposite operations, we can also write that c divided by a equal to b and c divided by b equal to a. So when we want to divide c by a, what we want to do is we want to find a number that will multiply with a and produce c. So to find that number, what we do is we factorize c. So c is a times b and we divide it by a and we cancel the common factors. So here we cancel a from both numerator and denominator and we get the answer b. So that's how we do division of natural numbers. So let's just extend that to the division of integers. So we already have a times b equal to c. So let's multiply the both sides by minus 1. So I'm multiplying minus 1 on the both sides. Now I can write this multiplication as minus a times b equal to minus c. And why I could do that? That's because of associativity of multiplication. So here I have grouped minus 1 and a and that produces minus a. Okay, so now we can write that minus c divided by minus a equal to b and minus c divided by b equal to minus a. That just follows from this statement. So once we know that minus a times b equal to minus c, we can just write these division statements. And note that I'm dividing two negative numbers and the outcome is positive. And if I divide a negative number with a positive number, outcome is negative. So let's just look at it closely again. So we have minus a times b equal to minus c, and from that we know that minus c divided by minus a is b and minus c divided by b is minus a. And why we can do this division, why this answer comes out, is because let's expand this minus c divided by minus a. So I can factorize c as a times b. So I have minus of a times b divided by minus a. Now I'm just writing minus as minus 1 times a times b, and in the denominator also I'm just writing minus a as minus 1 times a. In this step, I am just using associativity. I am just degrouping the multiplication. So I have just written the numbers in the plain order. And now I can cancel the common factors. I can cancel minus 1 and I can cancel a here and I'm left with b. And that's how minus c divided by minus a is b. Similarly, if we want to do minus c by b, we will again factorize c as a times b. Minus sign, we'll write it as minus 1 times a times b, and here we'll just cancel the common factors. So b is a common factor and we are left with minus 1 times a, and answer is minus a. So that's the general rule. So when we are given any numerator and denominator, we just factorize numerator and denominator and cancel the common factors. So now we know how to divide a negative integer with a positive integer and a negative integer with a negative integer. So let's continue to look at the whole numbers example again. So a times b equal to c, all are positive integers. I can write it as 1 times a times b equal to c, and that's because 1 is multiplicative identity. Now I can write 1 as minus 1 times minus 1, and a times b remains same. So that's because we know that we can split 1 as even number of minus 1s. Now I'm rearranging minus 1, this minus 1 to here, and that's because I'm using commutativity of multiplication. I am swapping one a and minus 1. I have regrouped minus 1 and a and minus 1 and b. So I'm using associativity of multiplication, and now I am left with minus a times minus b equal to c. So now you may wonder that why did I do all these things? I could have just written minus a times minus b equal to c, because we already know how the multiplication works. But I just wanted to stress the associativity and commutativity properties of multiplication, so that we are aware that when we do each step, we should know what property we are invoking. So from that, now we know that minus a times minus b equal to c, and we can write c times minus a equal to minus b, and c times minus b equal to minus a. So we are dividing a positive integer with a negative integer, and the answer we get is a negative number. So let's see that again. So c times minus a equal to minus b, and why is that? That's again, we just factorize the numbers as before. So c is factorized as a times b and divided by minus a. So now I can write a times b as 1 times a times b, and again I can split this one into two minus ones, and I can split minus a as minus 1 times a, and we have minus 1 times minus 1 times a times b in the numerator and minus 1 times a in the denominator. And now we can just cancel the common factors. We can cancel minus 1 and we can cancel a, and we are left with minus 1 times b, and that's the answer we have. So we have seen how to divide positive and negative integers. So what we know, that when we do the division, we just divide the whole numbers and attach a sign based on the signs of numerator and denominator. So if we are dividing a positive number by a positive number, quotient is positive. If I am dividing positive number by a negative number, quotient is negative. If I'm dividing negative number by a positive number, it's negative again. And if I'm dividing a negative number with a negative number, the quotient is positive. But I would urge that don't remember this table. We should just use this factorization logic everywhere, whether the dividend is positive or negative, or divisor is positive or negative. Just factorize it as minus 1 times the whole number, and from that it is just apparent what to do. So let's take an example. So we want to divide this numerator, that is 27 times 25 times 68, by the denominator minus 6 times minus 15 times minus 30. So the naive way would be, we will do this multiplication first and get the numerator, do this multiplication and get the denominator, and do the division. So while dividing, we will factorize them again and cancel the common factors. So instead of doing that, we don't have to do this multiplication. We can factorize the multipliers themselves. So let's just factorize each number. So 27 I'm factorizing at 3 times 3 times 3, and same way I'm factorizing all the numbers. The denominator minus sign is taken out as a factor minus 1 in each of these numbers. And now we can cancel the common factors. So here I can cancel this 3 from this 3, this 3 from this 3, and here we are using both associativity and commutativity property. We all know that, so I'm not going to show it again, but we know that we have used these two properties to cancel these factors. And now we can cancel all the common factors, that is 5. So we have 5 here and 5 here and 5 here and 5 here. So I'm canceling all the 5s. Now let's cancel 2's. 2 here and 2 here, cancels 2 here and here. Now we are left with 17 in the numerator, and in the denominator it's minus 1 times minus 1 times minus 1. So a train of minus ones with three minus ones, so we know that multiplication is minus 1. And now we can write 17 as 1 times 17, which is because 1 is multiplicative identity. I can split this one as minus 1 times minus 1, and now I can cancel minus 1 and minus 1. So I am left with minus 17. So minus 17 is the answer. So before we move on to the properties of division, just a reminder to subscribe to this channel. If you have any questions or doubts, please feel free to ask them in the comments, or you can go to abhyasu.com and ask them there. These lectures are live every day, Monday to Friday at 7 p.m. So let's look at some properties of integer division. So let's take a look at commutativity. Is integer division commutative? That is A divided by B same as B divided by A? So let's take an example. 40 divided by 5 and 5 divided by 40. So the first division we know the answer is 8, and second division we know that the answer has to be less than 1. So it's not the same. So integer division is not commutative. How about associativity? So is integer division associative? That is, if I want to do A divided by B divided by C, I do A divided by B first and then divided by C. Is it same as A divided by B by C? So as an example, let's take a look at 25 divided by 5 and then divided by 5. So 25 by 5 will be 5 and 5 by 5 is 1. Versus I group 5 and 5 first. So 5 divided by 5 will be 1 and 25 divided by 1 will be 25. So again, the answers are not same and integer division is not associative. How about closure? Are integers closed under division? That is, if I take two integers A and B, is A divided by B an integer for any A and B? So let's take an example. So say 13 by 5, and we know that that is not an integer. So integers are not closed under division also. So division is not commutative, not associative, and integers are not closed under division. Let's take a look at division by some special numbers. That is division by 0, 1 and minus 1. So division by 0 is not defined for integers. So A by 0 is not defined. As a side note though, you can divide 0 by any integer and the answer is 0. So 0 by A is 0, but A has to be non-zero. So again, 0 by 0 is not defined, but 0 by A is 0. If we divide any integer by 1, the answer remains the same as that integer. A by 1 is A, and that's because A1 is a multiplicative identity. So I can write A times 1 as A, and which also means that A divided by 1 is A. So if we want to do divide by minus 1, so A divided by minus 1, we'll just use our factorization logic. So I write A as 1 times A because 1 is multiplicative identity, and then split this one as 2 minus 1s. So minus 1 times A, and now we cancel the common minus 1 from numerator and denominator, and we are left with minus A. So A times minus 1 is minus A. So we just flip the sign when we divide by minus 1. So those are some simple rules and properties of integer division. So hope you are comfortable with integer division. So that's all we have for this lecture. Thank you and see you.